Yes,
Morning.
ma'am.
Good morning, ma'am.
Good morning.
Good morning. Do you have any noise or my voice is clear to you?
No, ma'am. Noise
We
వస్తుంది,
have
ma'am.
noise, ma'am.
Good morning. Voice is clear?
Ma'am.
Yes,
Okay,
ma'am.
good. Okay, good. Right. Now, let us discuss about the remaining concepts of our differential amplifiers. Okay.
I'm
Yesterday,
getting some
what have
noise,
we
ma'am.
discussed? Okay, 1 minute. Only out of 64, only 32 are here. Right. We'll observe how long you are in the class, right? If you are more than certain period only, you will be getting attendance. Please keep that in mind. Okay. For example, uh, in the previous class, L Maulika entered into the class at 9:56 and left class at 9:57. That's all. She did not join again. So such people will lose their attendance. That is one bad example I can say. And another good example is Venkata Rakesh. Are you here now? K. Venkata Rakesh. Are you here? Ah, yes. Right. He tried to join at 8:54 for 9 o'clock class, and he left at 8:54.6 seconds, and he left at 22 seconds. Again, 8:57.21 he joined, and he left at 8:57.28. After that, he joined the class at 8:59.57 seconds, and till the end he did not leave the class. So why I want to tell you all this information is, here everything is recorded. You are logging into the class, joining time and leaving time, everything is recorded. So unless if you are there in the class for full time, right, you may not get attendance. So my sincere request to you all, you please enter the class and you join the class on time, and you leave the class only at the end of the class. Okay, before that you please don't do. So we are observing everything. Please take care of your uh, what is that, attendance. Right. Now let us see. Previous class we have studied about swamping resistors, right? What is the purpose of using these swamping resistors? What is the purpose of using these swamping resistors? Yes. Why we have used swamping resistors?
Reduce the
Reduce
impact of
impact of
small
RE on
Very
differential
good,
gain.
very good, very good. Right, right. So to reduce the effect of small RE, emitter resistance, on differential gain of the amplifier, swamping resistors are used. Okay. So this is what type of circuit it is. What I am showing is, what is the circuit? What is this circuit?
QL input balanced differential amp.
Balance output differential amplifier plus with real input balanced output differential amplifier with
Swamping
Swamping
this.
resistor.
yes, with the swamping resistors,
Swamping
right?
resistor.
So this is a dual input balanced output differential amplifier with the swamping resistors. Okay. So in place of what is that, a small RE, we have added RE dash, swamping resistors we have added, right? So yesterday we have discussed thoroughly, right? This is just a recap only. When we add a small a huge resistance, large resistance here, right, what will happen? Differential gain varies and input resistance also varies. Wherever you have R small e, we have replaced it with RE plus RE, which that is swamping resistor, right? So that Re, this entire thing we call it as swamping resistor, right? So input resistance also varies because at the input side of the amplifier only we have added one more resistance, right? So therefore this is not there. So therefore it is equal to input resistance Ri1 is equal to Ri2 is equal to 2 beta into Re plus Re dash, which is a swamping resistor that you have added, right? Earlier we have 2 beta acre, that means 2 beta AC into Re only. Now in series with Re, you have added another resistor named Re dash, which is also called as swamping resistor. All these we have discussed, right? Then output resistance, does the swamping resistor affects output resistance of our differential amplifier?
No.
No, because
No,
the resistance that we have added is at the input circuit of the differential amplifier. So at the output side we have no effect, no effect. That means swamping resistor effect is not there at the output of the differential amplifier. Okay, and then we have seen what are the advantages. I think before this we also have seen what are the different methods to add to increase this input resistance. That is these methods are using Darlington pair, use of field effect transistor, and use of swamping resistors, right? Use of swamping resistor, use of field effect transistor, and we can also use Darlington pair amplifier, right? So what is a swamping resistor now? I have given you this definition also, right? So swamping resistor, what is a swamping resistor means the resistors which are connected in series with emitter resistance, right? Resistors which are connected in series with emitter resistance to increase the input resistance, to increase the input resistance. So the corresponding circuit is this, and these are the arrangements. And now we have finally expressed differential gain, input resistance, and output resistance of differential amplifier. Okay. So after that we have seen advantages of swamping resistors. So when we add these swamping resistors, input resistance will be very high. And then what is the main advantage? The linearity range of the differential amplifier increases. That is the main advantage, right? Because if you do not add these swamping resistors, gain of the amplifier, what happens now? It will be decreasing, it will be increasing as there are variations in the temperature. Accordingly, there will be variations in Re. Because of these variations in Re due to temperature, there will be wide variations in differential gain of the amplifier. Now, when we add this swamping resistor, the gain will be linear and it will be stable. It will not be zigzag, right? That is the biggest advantage of adding swamping resistors. And after that, the minimize it, this swamping resistors minimize the changes in the transistor parameters due to temperature, right? So these are the main advantages of swamping resistors, right? Now today we are going to learn something new. That means what all we have studied now, their application only, right? So by seeing the circuit, you may feel that my God, such a big circuit in LICA subject. So how to learn these biggest circuits? You may feel just at a glance, right? Now, if you understand what it is exactly, this circuit is nothing, right? What all you have studied only is kept here, right? So let us see the next topic in our unit 1 is cascaded differential amplifier stages. Till now we have seen just a differential amplifier, that is 4 configurations we have seen. What are the 4 configurations? You tell me.
Dual input, balanced output, dual
Very
input,
good.
unbalanced
Dual
input.
input, balanced
Single input,
Dual
output.
input,
balances, single input.
unbalanced output.
Dual input, unbalanced output. Very good.
Single input.
What is that? People are like that you are saying. Say clearly. Third configuration.
Single
Single
input,
input,
balanced
balance.
output.
Very good.
Output.
Single input, balanced output.
Single
Fourth
input,
configuration.
amplifier.
Single input,
Balanced output.
unbalanced output. Okay. So all these four configurations, what we have derived, differential gain, then
Input resistance,
input
output
resistance
resistance.
and output resistance. Okay, so all these we have derived, and I also asked you to what is that, derive all these in a separate assignment book, and I may ask you to upload or submit accordingly, right? So now today's class, what we are going to learn is cascaded differential amplifiers. Okay, so we know what is a differential amplifier. All four configurations we have seen, right? So differential amplifier, all four configurations we have seen. I don't have that much good control on mouse sometimes, right? Differential amplifier we know. Now what do you mean by this cascade? Anyone? What do you mean by cascaded?
Connecting side by side, man.
Connecting side by side.
Why connecting side by side is required?
Higher gain, man.
Very good, right? So anyhow, you tried your best to give a good answer, right? Now, why we go for cascading of amplifiers means, you see, one amplifier has gain A1 and another amplifier has gain A2. Okay, let us see one example, right? In our seminar hall, if all third year students, how many total, 180 or 182, something like that. Okay, if all final year students and third year students sit in our seminar hall, now directors or principals or someone is speaking from the dais, right? Now, can you hear, if they do not use any mic system or anything, can you hear their voice if you sit at the end of the seminar hall?
No, ma'am.
No,
No,
that's why
ma'am.
what we do, we use a public address system that is having some amplifier circuit, right? So now the guest is on the dais, right? They are talking by using a microphone, right? So what is the purpose of microphone here? What is a microphone?
Amplify voice signal.
Convert the
Right.
speech signals into electrical signals.
Very good, right? Very good, right? So microphone, short form, we call it as mic, right? This microphone is a transducer which converts sound waves into electrical signals, right? So microphone has converted sound waves into electrical signals. Then what we do after that? Those electrical signals are applied to an amplifier, right? Those electrical signals are applied to amplifier. Then what will happen? The speaker's voice is amplified, right? Previously the speaker's voice is this much only. Now the speaker's voice will be with that much amplitude. Okay, right? So I did not draw properly, right? So this is the signal. Speaker's voice is with this much magnitude earlier, and now frequency doesn't change. Okay, now the amplitude increases, and that is the frequency is same, time period is same, right? Only the magnitude of the signal after amplification, this is the magnitude of the signal, right? Now amplifier amplifies that signal. After that what will happen? How do we hear that signal? From where we hear the signal of the speaker on the dais? From where, if we are sitting in the end of the seminar hall, in our seminar hall, from where you hear the sound?
Speakers, man.
Yes?
Speakers, ma'am.
Yes, speaker. What is a speaker? What is a speaker?
Converting the electrical form into
Converting
audio form.
electrical signal into speaker speech signals.
Yes, sound waves, right? So it does the opposite work of the work done by what is that? Microphone.
Microphone.
Microphone converts what is that? Sound signals into electrical
Voice
signals.
sound signals to
Electrical
electrical signals.
signals, and speaker converts electrical signals into sound waves. That's why sound waves will be coming out of this speaker and you will be able to hear the magnified version of the signal. That's why when speaker, I mean when the speaker means when the guest is speaking during the speech, if power goes, you cannot hear anything because no amplification, right? So like that, we use one amplifier to amplify the signal, right? Now let us assume that the gain of the amplifier is 1 a1, right? And when we want more gain, that means let us assume that the gain of stage 1 is 10, right? So 10 dBs is not sufficient for our particular application. So therefore what we do, we go for another stage with another gain. That means same stage you can repeat or according to your requirement. So now if we assume that there are two amplifier stages and when they are cascaded, what do you mean by cascading? Output of first stage is connected to the input of the second stage, right? Output of first stage is connected to the input of the second stage. Now first stage we give input. Input signal is first amplified with gain 10 dB, and that same amplified version of the first signal is applied to second stage. Now it will amplify with one more 10, so the overall gain will be increased, and overall gain A is equal to how much, you tell me? Overall gain A is equal to, in cascaded stages, what is
A1 plus A2.
overall gain is equal to
20 dB, ma'am.
A1
A1 plus
20
A2,
dB,
ma'am.
ma'am.
one of you,
A1
one
plus
of you.
A2
A1,
plus A2.
is it A1 plus A2? It is multiplication. A1 A2 we will get. Okay, so the overall gain of the, you have derived this in multi-stage amplifiers. Okay, so when you derive, you will get overall gain A is equal to A1 A2. So if the single stage amplifier has gain of 10 and 3 such stages are cascaded, what is the overall gain of the amplifier? So this will be the question in your GATE or IES exams. If at all, if the question paper is very easy, then you will get this type of small simple question, right? 3 stages of identical amplifiers are cascaded, then what is the overall gain of the amplifier? So each stage having gain of 10. So how much, what is the overall gain? I repeat, there are 3 amplifier stages cascaded. Assume
1000,
all
ma'am.
these 3 stages are identical. So that means each stage has gain of 10. So 3 such stages are cascaded. What is the overall gain of the amplifier?
1000.
How much?
1000, ma'am.
Very good. Exactly. Right? That is A1, A2, A3. That is 1000. So when you cascade some amplifiers more than one stage, you can understand how much gain it is possible to achieve. Right? So now when the gain is increased, what happens to bandwidth? Gain is increased, okay. In multi-stage amplifiers or in cascaded amplifier, gain is increased, okay. What happens to bandwidth? Bandwidth. What happens to bandwidth? The way I asked my question, you can guess. Bandwidth increases or decreases?
Increases.
Huh? I
Increases,
can
ma'am.
hear
Increases.
I can hear crease only. Increase or decrease, one of you?
Increases.
Increases. Decreases. Okay, you tell me upward arrow or downward arrow?
Upward arrow.
Upward arrow, someone. Then any other person downward arrow?
Yes, ma'am.
All are saying bandwidth also increases.
Bandwidth
See,
decreases.
no, upward arrow or downward arrow? Bandwidth increases or decreases? I am asking you to express upward or downward.
Increases, ma'am.
Increases. No. Gain bandwidth product is constant, right? So for any amplifier, you have derived all these. Gain bandwidth product is constant, right? So now what happens means when you increase the gain of the amplifier, bandwidth decreases, right? Finally, gain bandwidth product is equal to constant. Gain bandwidth product is equal to constant, right? So you please remember, this is the gain of the amplifier, frequency response of the amplifier. So, and this is the frequency response of the amplifier. So figure A shows frequency response of one amplifier. Figure A shows frequency response of one amplifier. Figure B shows frequency response of another amplifier. Now out of these two, which amplifier has high gain, A or B?
A.
Which amplifier?
ma'am.
A or B?
A.
Emarra, I think you don't remember frequency response also, right? Along x-axis frequency, along y-axis gain. This is gain and this is gain. Which amplifier has high gain? A or
B,
B?
ma'am.
B, right?
B.
If I draw, what is that? Axis and all you are telling, otherwise without drawing axis you are not able to guess, right? Electronic students, you must remember all these, right? So the frequency, which amplifier has high gain? Figure B, right? Which amplifier has high bandwidth? Which amplifier has high bandwidth?
A, ma'am.
A. How can you say? You are exactly correct. Maximum and 3 dB down, right? 3 dB
Yeah.
means this one,
Yes.
and this is the other point. So from here to here, this is bandwidth, right? And for figure B, this is maximum and 3 dB down. So when you mouse went that side. So when you draw these 2 points, project these 2 points, right? You will get very small value of bandwidth, right? So this is the bandwidth. So figure B has less bandwidth. So here what I want to convey is, in the cascaded stages, you will achieve very high gain. You will achieve very high gain, right? So therefore, when you achieve high gain, bandwidth will be reduced. Bandwidth will be reduced. Why when you get high gain, bandwidth is reducing? Why when you get high gain, bandwidth is reducing? Just now I have mentioned. Just now I have mentioned, when you increase gain, why bandwidth is reducing? Yes? Gain bandwidth product is constant, right? Yes, gain bandwidth product is constant. Therefore, if you increase one, the other one gets decreased, right? So gain bandwidth product of the amplifier is constant. That's why if you increase one and other parameter gets decreased. Followed? right? So with this minimum knowledge now, that means you know all these, but just I have recollected your knowledge from your memory, right? Now let us see the cascaded differential amplifier. Just now what I have mentioned is, in general, what are the differential amplifiers? All that. What is the cascaded amplifier? All that. Now let me tell you what is this cascaded differential amplifier. Till now I tried my best to convey what is cascaded stage, right? So what is a cascaded stage? What is the advantage of this cascaded stage? Yes, what is the advantage of cascaded stage?
Gain increases.
Yes, exactly. Very good, right? So when we go for cascaded stages, we can achieve very high gain, right? So when we achieve high gain, what happens to the bandwidth?
Decreases.
Decreases.
Decreases. So why bandwidth decreases?
Gain
Bandwidth.
bandwidth product
Gain
is
bandwidth
constant.
is constant.
Constant. Very good, very good, very good, right? So now let us see this cascaded differential amplifier, right? So is our today's topic is cascaded differential amplifier. You know what is cascaded stage, and then you know already what is a differential amplifier. Now let us see, these are the two differential amplifiers cascaded, right? So please note down this circuit, right? These are the two differential amplifiers cascaded. This is stage 1 and this is stage 2, right? Stage 1 and stage 2. So what is cascading, right? Series connection of differential amplifiers. That means output of first stage is connected to the input of the second stage. Just now we have defined. So first let us forget about the second stage, right? Let us forget about the second stage. Now all of you look at the first stage only. So how many inputs this first stage has?
Dual input.
Two inputs, right? One is inverting, other one is non-inverting, but it has two inputs. So it is dual input. Dual input. After that, you tell me.
Balance
We
out.
know that this is a differential amplifier. It has two inputs. One base is connected to one input, other base is connected to other input. So stage 1 is dual input. Output is taken where?
Collectors
Output
of
is taken
Collectors
both
of
the collectors of two
constant.
both the
amplifiers.
collectors. Therefore, what type of output it is?
Dual input, balanced output.
Balanced
Balanced output.
Very good, very good. You people are learning this subject. I am happy. Right? It is a dual input, balanced output differential amplifier. Is this dual input, balanced output differential amplifier new to you? You are very much familiar with dual input, balanced output differential amplifier. Yes, right. So you please take this stage 1 first, right? So stage 1, it is not at all new to us. It is a dual input balanced output differential amplifier, right? So then let us come to the second stage. Second stage. So output of first stage. This output is connected to this base. So one input, and this output is connected to the base of second transistor. So what is the second stage? This is also a dual input stage. Dual input.
Unbalanced output.
Yes, exactly. Right. Where output is taken only from
Single
one
collector.
one collector. Therefore, it is a single-ended output. Therefore, it is dual input and unbalanced output. Dual input and unbalanced output differential amplifier, right? So, this circuit is looking very big, but it is very, very familiar to us. It is nothing but a differential amplifier. Two differential amplifier stages are cascaded. One is dual input balanced output differential first stage. Second stage is dual input unbalanced output differential amplifier, right? So dual input, unbalanced output, dual input, balanced output. So two differential amplifiers are cascaded. So this is a cascaded differential amplifier stage. This is the, this is the direct topic in your syllabus, unit 1 syllabus. So I am just showing the dual input balanced output differential amplifier cascaded stages, that is cascaded differential amplifier. So here we know what is stage 1 and what is stage 2, all their analysis. So nothing is new for us here. So their analysis is same what we have carried out earlier. Just you try to understand that we can cascade differential amplifiers also to achieve higher gain, right? So why we are talking about cascaded differential amplifier stage means these cascaded differential amplifier stages are used at the input of the operational amplifier, right? So basically what I said, our subject is LICA linear IC applications. Here first part of the syllabus, that is first 3 units, we study about what is that, operational amplifier IC 741, right? This IC 741 or the operational amplifier uses differential amplifiers in it. Now you can say, you can understand that the cascaded differential amplifier stages are used at the input of the operational amplifier, right? That's why we are just showing the cascaded differential amplifier stage, right? So here some requirement you have to remember, right? So what are the requirements in this cascaded stage is, main requirement in cascaded stages is perfect matching of transistors that you are using should be there. Q1 and Q2 should match perfectly, and Q3 and Q4 they should match perfectly. Then only we will get proper characteristics, right? So that is the main requirement. And another requirement is resistor RC1 is equal to RC2 we have written. So they should match perfectly, right? So you know what is that? Your brothers and sisters, right? Your parents have 2 children, right? Sometimes identical twins and sometimes non-identical twins, right? So though they are identical twins, there will be some variations. So similarly here also, the manufacturers, they manufacture same resistor with the same specifications. They should match properly. There should not be any variation. In such a way we have to select resistance values, except that remaining things are same. So this is what about cascaded differential amplifier stages. This analysis is not required. Here you understand that what is a cascaded differential amplifier stage, right? Hello, right? This is a cascaded differential amplifier stage, right? Then let us see the next topic, next circuit, that is see about this circuit I have given you. If at all, if my voice is not clear or something like that, so I have once again mentioned here, typed here. First stage of the cascaded differential amplifier is dual input balanced output differential amplifier, and second stage of the differential amplifier is dual input unbalanced output differential amplifier. And the main requirement that is required also I have mentioned, that is perfect matching of transistors and resistance values, right? So this is what about cascaded differential amplifier stages, right? Then I just want to show you at this moment the block diagram of a typical operational amplifier. Always I am telling you that the opamp uses differential amplifiers. Okay, let us see the block diagram of a typical operational amplifier, right? So what are the various blocks? Let us see. the input stage, right? First stage is input stage, and at the output we have output stage, right? And there are some intermediate stages. So intermediate stage, and there is some level shifting stage. So these are the basic building blocks, right? So this is the block diagram of a typical operational amplifier, right? Typical operational amplifier has 4 blocks mainly. Now let us see. Input stage, input is given. Output stage, output we have taken. In between, what are the various stages? In general, we have mentioned that this is the input stage, this is the intermediate stage, this is the level shifting stage. So what is this input stage means? At the input stage of the operational amplifier, dual input balanced output differential amplifier is used, right? So at the input stage of the operational amplifier, what is used? Dual input balanced output differential amplifier. Then at the intermediate stage of the operational amplifier, what is used? Dual input unbalanced output differential amplifier. Just now I have mentioned these two stages are cascaded in cascaded differential amplifier. So these two are used here, right? So at the input stage, differential amplifier, that is dual input balanced output differential amplifier. At the intermediate stage, dual input unbalanced output differential amplifier is used. So that means in an operational amplifier, in an operational amplifier, differential amplifiers are used. So those are the differential amplifiers that are used, and we know thoroughly what these are, right? Then after that, there is another stage called level shifting stage, right? There is another stage called level shifting stage. So about this level shifting stage, we are going to learn in the next class, right? So about this level shifting stage, we are going to learn in the next class. And after that, the output stage, right? So output stage. See, we have studied about input stage, and we have studied about intermediate stage, and we are going to study about level shifting stage tomorrow, and later, 1 minute, okay. Right? Later, let us see what is the output stage, right? So always I am telling you, these are the various internal blocks in op-amp. So now itself I want to show this block diagram of a typical op-amp. So level shifting stage, that means some what is that, emitter follower or some other circuits are used at a level shifting stage. So different circuits are used. Approximately there are some very small simple level shifting circuit to a good excellent level shifting stage circuits, level shifting circuits we are going to study in tomorrow's class. Now let us also see the output stage, right? So what is this output stage? So at the output stage of the operational amplifier, what is used? Complementary symmetry push-pull amplifier, right? Complementary symmetry push-pull amplifier. So what type of amplifier this is? This is a power amplifier. Have you studied power amplifiers in your ECA? Have you studied power amplifiers? Class A power amplifier, Class B
Yes,
power
Yes,
ma'am.
ma'am.
Class C power amplifier, all that efficiency derivation, all that you have done, right? So there you might have studied about complementary symmetric push-pull power amplifier. So at the output stage of the operational amplifier, these complementary symmetry push-pull amplifiers are used, right? So only in unit 1 we study what is there inside the operational amplifier, right? Only in unit 1 we study what is there inside the operational amplifier. from unit 2 onwards, we take operational amplifier as it is and we just indicate input terminal, that means non-inverting input and inverting input, and we take output, that's all. That means op-amp in IC form, right? That is op-amp, right? 2 inputs and 1 output, that's all. Of course, this is plus VCC minus VEE we draw. So when we draw plus VCC and minus VEE, those are the voltages that we are writing in our KVL, in the dual input balanced output differential amplifier circuit. Okay, those. And input, 2 inputs means one is non-inverting input, other one is inverting input. Output is this. So in the second unit, from second unit onwards, we consider op-amp like this only. Only in unit 1, we study thoroughly what is there inside, right? When you go to doctor, if your grandparents or aged people, if they go to doctor and if they say that they have some pain in their heart, right? So doctor will observe, right? Otherwise, if they have some problem, if someone gets fever and visits doctor, they use stethoscope and they observe the pulse of the patient. So stethoscope, do they put their stethoscope on hands or on legs? No, right? So they put in the respective place where heartbeat takes place, or where from backside lungs, their expansion, contraction, whether it is taking properly or not. That means doctor knows where the heart is and where the lungs are, where the kidneys are, all that. Similarly, our electronics engineers, they know when we say operational amplifier, what is there inside the operational amplifier, right? So inside the operational amplifier, dual input balanced output differential amplifier is there, right? And also some balanced output and unbalanced output, accordingly some cascaded stages, and after that some level shifting stage is also required. Why this level shifting is required, we will discuss in tomorrow's class. Today it is not possible to complete that topic. So level shifting we shall see tomorrow, all the circuits, and after that there are some output stages. That means op-amp IC has some differential amplifiers, some cascaded differential amplifiers, some emitter follower or level shifting circuits, and power amplifiers, right? So these many circuits are placed inside the operational amplifier IC, right? So now are you able to follow the block diagram of a typical op-amp? How many blocks are there? How many blocks are there?
4, ma'am.
Block.
4
4,
blocks
ma'am.
are there, right? First stage, first one,
Input
Input
stage.
Input
stage.
stage.
second one,
Intermediate
Intermediate stage.
Intermediate stage.
third one,
Level
Level
shifting
shifting.
level
stage.
shifting stage, fourth one,
Output
Output
stage.
stage.
output stage. And one of you tell me where dual input unbalanced output amplifier is placed in op-amp?
Input
stage.
Intermediate.
Intermediate stage. Where
Intermediate.
complementary push-pull amplifier is used in op-amp?
Stage.
Output
Output
stage.
Where dual input balanced output differential amplifier is used in op-amp?
Input.
Input
Input
stage.
stage.
Input stage.
Okay, so what is a level shifting stage? In level shifting stage, what type of circuits are used? Emitter follower.
Emitter follower.
Right?
Emitter
So what
follower.
is this emitter follower? You please, emitter follower means what? Emitter follows, right? That means the output follows the input. What is the other name for emitter follower? Which configuration it is? Emitter follower means it is CB or C or CC?
C.
C, ma'am.
C,
C.
C, right?
C.
So common collector amplifier is also called as emitter follower, right? So the output follows the input. Emitter is at the input in common collector stage. Collector is common to both input and output. Okay. So output follows the input. That's why common collector amplifier is also called as emitter follower. That's why output voltage is equal to input voltage. Therefore, the gain of the voltage gain of the common collector amplifier AV is equal to V naught by V in is equal to how much? How much? Common collector amplifier, other name is emitter follower. That means output follows the input. Whatever input you give, same will appear at the output. Okay. Now, what is the gain, voltage gain of the common collector amplifier or emitter follower? What is the gain? V naught by V in. What is V naught? What is V in? Yes?
Both are
voltage
same.
being
Both are
voltage.
same.
Both are same. Very good. When both are same, what is the gain?
1.
1. Very good.
One.
Right?
Unity.
So, emitter follower gain is almost close to unity. Right? Emitter follower gain is almost close to unity. That means here only you are not increasing any gain. Whatever gain is required in these previous stages only, you will increase the gain of the amplifier. So here, when you use this emitter follower here, you are just doing some other purpose. That means you are connecting this emitter follower not for any amplification or not for any gain increase, but for some other purpose, that is without adding any gain. What you are going to do is you are going to have some level shifting. What is this level shifting? All that we shall discuss in the next class, right? I think we are coming close to the end of the class, so let me move little forward, right? So this is the intermediate stage, right? So only single input stage of the amplifier, single input stage, that means with the single dual input balanced output differential amplifier, gain is AD is equal to RC by RE. So with the single input stage, it is not sufficient to have sufficient gain. Therefore, this intermediate stage provides high gain. Okay, that means intermediate stage is nothing but the cascaded stage of differential amplifiers. Therefore, with this cascaded stage, it is possible to have very high gain, right? So the main function of the intermediate stage is to provide additional voltage gain, right? So how much gain is required? So with that much gain is achieved by using these intermediate stages, right? Intermediate stage, right? So practically we are saying intermediate stage, but intermediate stage is not a single amplifier, it is a chain of cascaded amplifiers called as multi-stage amplifiers, right? So what is an intermediate stage? Intermediate stage is not a single amplifier stage, it is a chain of cascaded amplifier stages, which is also called as multi-stage amplifier, right? So therefore, what is the requirement for intermediate stage? Let me show you. This is the intermediate stage, right? So we have mentioned that dual in intermediate stage, dual input unbalanced output differential amplifier is used. So this intermediate stage is not a single stage amplifier. There a chain of amplifiers are cascaded chain of amplifiers are used. How many amplifier stages you are planning to cascade means to achieve the required gain. What is the gain that is required? That means using your op-amp, it is possible to have very high gain, right? So that is the advantage, right? So the intermediate stage has not only single amplifier, but it has a chain of cascaded amplifier stages. So cascaded amplifiers, we also call it as multi-stage amplifiers. and just now I have mentioned what is the gain in a multi-stage amplifier, right? So now let us see the requirements of intermediate stages, right? Intermediate stage. So what is the purpose of this intermediate stage? Means it should be able to provide very high voltage gain, right? Very high voltage gain. Then another more important, let me take in between, I have taken your attendance, right? Let me also take your attendance once again, right? There are 61 students, right? Good. Right. So the intermediate stage, it should provide very high voltage gain, right? Sima, at the beginning of the class only 20 to 21 students like that, but at the end of the class there are 61 and 62 students. Yesterday I felt very very happy because my section C students are very good, they are excellent, because out of 64, 62 are attending. But when I saw your retention ratio, some of you are leaving the class early, right? So you please see that you stay in the class fully, right? Whatever may be the situation, right? Whether COVID is there or not. So we are going to continue our lives. We are going to continue our studies. We are going to continue our jobs. Everything. We are going to carry out our life as usual. Therefore, you focus more and more on your studies. And there is Emma, what is that? Sairam, number 4, 4B to Sairam. Okay, right? You call me later. 4B to Sairam. You call me later. I don't want to waste others' time, right? Okay. So the main requirement for intermediate stage amplifiers is it should provide very high voltage gain. And one more very important parameter is the direct coupling without coupling capacitors, right? So you have studied about amplifiers. Have you studied about RC coupled amplifier? RC coupled amplifier.
Yes, ma'am.
Yes,
Yes,
right?
ma'am.
So why it is called as RC coupled amplifier?
Resistors and capacitors are used in
Yes, right. So when
every
we use coupling capacitor, what happens means placing these capacitors inside the IC will be very difficult. Therefore, without using these coupling capacitors, when two stages are directly cascaded, it will be more advantageous. That's why the intermediate stage provides mainly two advantages. One is without using coupling capacitors, it will provide direct coupling, right? So in your syllabus, a word direct coupling is used. It is nothing but intermediate stage only. So intermediate stage will provide direct coupling without coupling capacitors. Stage 1 is coupled to stage 2 directly, right? So that is one biggest advantage. And the second one is very high voltage gain. So these are the two expectations that are expected from intermediate stage. That means you are the electronics engineer, you are designing the amplifier or you are designing a circuit. So how you have to design this intermediate stage, keeping two factors in mind. What are the two factors? One is this intermediate stage should provide
very high voltage.
very high voltage gain. The second parameter is
Direct coupling without
Direct
coupling
without
coupling.
using coupling capacitors, this intermediate stage should provide direct coupling, right? So this is what about what is that? Cascaded stages, cascaded differential amplifier stages, and this is about intermediate stage. So Without showing that block diagram, you cannot understand what is this intermediate stage. Therefore, here I have inserted the block diagram of a typical op-amp. So typical op-amp consists of 4 blocks, and all these we have seen, right? So now what I want to convey is we have almost come to the end of unit 1. Only level shifting stage we will study in next class. Meanwhile, what I ask you to do is you please get ready for your assignment submission, right? So I just what is that, previous question papers questions, you will be having previous question papers. If possible, I try to upload. I think we in Teams we have the facility to upload this, so I try to upload these questions. So olden days we have to go to library and we have to search. Now everything we are giving, we just upload those questions. But still, let me read some essay questions which were given in previous question papers, right? In LICA question paper, right? So question number 1, in set 1 we got this. Derive the expression for voltage gain of a single input balanced output differential amplifier. I repeat, derive the expression for voltage gain of a single input balanced output differential amplifier. Can you derive this?
Yes, ma'am.
Yes, very good. Then you got 7 marks in your account from unit 1, right? Then that is for 7 marks. Same set 1 B part, draw the circuit diagram of a 2-stage differential amplifier and explain it. That is given for 7 marks. So draw the circuit diagram of a 2-stage differential amplifier and explain it. Can you draw that? Doubt, because I have not mentioned it as a 2-stage, right? So what is this? Cascaded differential amplifier.
Cascaded
Stage.
differential
How many
amplifier.
stages are there?
2 stage.
2
Two
stages.
Two
stages.
stages.
Oh yes, that's what. So draw the circuit diagram of a 2-stage differential amplifier means it is nothing but cascaded differential
Cascaded
amplifier
differential
stage.
amplifier.
So this is the circuit diagram that you have to draw, right? Explain it. Explain about it means by the time you draw the circuit diagram, it will take more time, and after that you talk about each stage. It has 2 stages, and individually about each stage you know, right? You just explain about. You also mention about swamping resistors, first stage, second stage, and Q1, Q2, emitter resistors, all that. Emitter resistors, VCC, RC1, all that you can explain, right? So what I have observed in from our previous batches is, because they understood this concept throughout. If the exam is for 3 hours, I mean mid examination I observed, right? Mid exam is for 1.5 hours, right? 1 hour they have taken for one question. Then what about other questions, right? So you have to plan in your examinations and you have to answer such big circuit diagrams carefully, right? So this is now. Do you have confidence that you can get 14 marks from unit 1?
Yes, ma'am.
Yes? Okay.
ma'am.
So, let me tell you set 2 also. Another question. Derive the expression for voltage gain of dual input unbalanced output differential amplifier. Can you answer?
Yes,
Yes, ma'am. Yes, ma'am.
Good. You will get 7 marks. Okay. Then one question is given for 14 marks. Draw the circuit diagram of all 4 differential amplifier configurations and write expressions for voltage gain, input resistance, output resistance. This is given for
Yes, ma'am.
14 marks. You get 14 marks?
Yes, ma'am. Yes, ma'am.
Yes.
Yes,
So,
ma'am.
yes, very good. Okay, remaining things I will cover in your what is that question paper. So I'll revise once again. So here I'll stop. We have reached 12:30, the end of our class, and then in the next class we shall discuss about the level translator, right? Level shifting circuit or level translator circuits. So once again, right? Good. So shall I stop here now for today? It is 12:30, right? So shall I stop here?
As
Yes,
well.
Have you
ma'am.
followed? Have you followed what all we have discussed today?
Yes, ma'am.
Very good. Okay.
Yes,
God
ma'am.
bless you all.